These are the approaches we looked at when investigating missing values in a data frame. Now, if we want to tell whether a column of a data frame has any instead of the entire data frame, we can pass the selected column as an argument to any of the approaches discussed. For instance, we can use the sum approach to test if the fourth column of our data frame has any. Yes, it does. Let us look at the fifth column. It does not have any. Typically, if you have a lot of columns to deal with, you want to test for NAs for all the columns at the same time. This is my preferred way of achieving this. You will momentarily understand what this line of code is doing. I will run it. We get a named logical vector. Here, true means the column has any. False means otherwise. I want us to get a good understanding of the concept in R, so let us take this a step at a time. Suppose we want to use the sum approach to tell the presence of any in each column. If we define our sum approach as a function, we can apply it to all the columns. Defining a function this way without giving it a name is what an anonymous function is about. Also, we can regard a data frame as a list, where each column is an element of the list. This can be done because R's data frame is built on top of a list. R has a nice way of applying the same function to each of the elements in a list or a vector. One of the functions we can use to apply another function over a list is the sapply function. This is how we implement it. We will supply the data frame as the first argument and the function we want to use over the list as the second argument. We get a named vector as the output. We see that while the RM column has no NAs, the H column has 20 NAs. Just before you get confused, the fact that if a column has a missing value, the count is 20 is just a coincidence that our data has that distribution of missing values. There is a function in R that sums the values of columns. We can use it in order to avoid defining our own and avoid using the sapply function altogether. It is called colSums. Instead of sum, we say colSums is.na. When we run it, we get the same result as before. If we want it in a long format data frame, we can wrap the code in data.frame function. I will just name the resultant column na_count. Now it is easy to read and know the columns with missing values. The following are other ways we could have investigated the missing values in each column. If we want to find the proportion of entries missing in each column, we use the colMeans function. If you remember from the previous tutorial, the indices approach we discussed gives us the rows and the columns that have NA for free. Here, the column index is wrapped in a table function to get the count of NAs in each column. It is also possible to determine if a row has NA and even count the number of NAs in each row. Make a copy of the previous line of code. We can replace the colSums function with rowSums function, and that should give us the result we want. For instance, there is one missing value in row 5. Sometimes we want to investigate columns or rows with no missing values. When a row has no missing value, we call that row complete. R allows for selecting columns or rows of a data frame using a logical vector. Thus, all columns in the position of true will be returned and those in the position of false will be discarded. When we did use the any function earlier, we had the logical vector we need. We can also modify our colSum's approach to give us the same logical vector by testing if a count is greater than 0. So, we can subset our data frame as follows. df, we will not put anything for the row index because we want all rows, and for the column, we can use any of the logical vectors. Running it, we get all the columns that have missing values. If we want the columns with no missing values, we can negate the logical vector using the bang negation operator or the exclamation sign. In most data analysis tasks, our interest is to work with a complete subset of the data, that is, the rows with no missing values. And with the help of the rowSum function, we can filter for those rows. There is a function from the stats package called complete.cases that is usually used to achieve the same result. I hope this tutorial adds to your knowledge of working with missing values in your data. If that is the case, please consider subscribing. Thanks for watching.